All right, level 3 chem. I want you guys to grab the notes from, I think it was a week ago now, on the galvanic cells, because I will be referencing this because I'm just finishing up this question and showing you what the excellence criteria is for this. So just as a reminder, what we did was we looked at the copper and the aluminum galvanic cell. We went through the achieve stuff. We figured out how to assign the two different half reactions. Just as a reminder for galvanic, you are looking to see where the two substances place. So we have copper and we have aluminum. We see which one ranks higher, and the higher ranking one is going to be our reduction reaction. That is a really crucial first step. If you get these the wrong way around, it's an automatic not achieved. I can't even give you a resub because that's a pretty major error. So watch out for that. Make sure you're assigning it the right way around. Very different from how you did the electrolytic. So that's why I want to remind you of that. That's also why I split the assessment into two halves, because I found in previous years that when I assessed the whole thing together, a lot of students got the rules confused for the two, and so I figured assess one first and then assess the second one next, so that way your brain doesn't get confused. This is just a little justification to why you assign which one which. Other thing for the achieved is just give me the change in oxidation numbers, or you can give me the gain and loss of electrons. Remember, the stuff that I've written in orange is just kind of extra stuff, or it's processing stuff. It's not stuff that I actually require. But if you do put that down, it does give me extra evidence to show that you know what's going on. Are we good so far? All right, so that was the achieved stuff. The merit stuff was just looking at your observations and trying to see what was going on at each electrode and in each beaker. Just be mindful that with the colorless ions, you should still be writing an observation, but you should be stating that you recognize that there isn't going to be an observable change because the ion itself is colorless, but there is a change in the concentration of that ion. So just kind of keep that in mind, and then you had your half equations and your E-cell calculations. Remember that it should always be positive in this case. Are we good so far? All right. So then for the excellence, what I'm looking for is the full equation. It's a really random thing that they require you guys to do, like when it comes to differentiating between achieved, merit, and excellence. In my personal opinion, if you're already aiming for the excellence, already aiming for the merit, you might as well try for the excellence, simply because the excellence doesn't have that much extra in comparison from the jump from achieved to merit. So just keep that in mind. Anyway, full redox equation, remember that we are combining these two together. The thing you are checking is the electron number. Electrons should be on opposite sides of the equation so they cancel out, and they should be the same number so that way they cancel out. In this case, I've purposely given you a more difficult one, simply because then you have to multiply both equations. If they're already equal, you don't have to do anything. You just got to put them together. So in this case, I notice that this one is 3 and this one is 2, so I need to find the closest common number that they share, which in this case is going to be 6. So I'm going to multiply this equation by 2, and this equation over here by 3. Now keep in mind that you are multiplying the whole equation, so 2's are going to go in front of the aluminiums, and 3's are going to go in front of the coppers. Are we okay with that? All right. Let's put that together then. So the nice thing about this being on a separate piece of paper is I can actually see them next to each other. All right, so I would have 2Al plus 3Cu2 plus, and then on this side I would have 2Al3 plus, and then 3Cu. And then that's that equation done. Be mindful with the equation, you should have one ion and one element. You should not have two elements or two ions in this case, because one's going from ion to element, one's going from element to ion. So different look compared to the electrolytic cell. Cool. All right, now let's talk about the justification. So I put in these two blanks in here, so that way we have that flexibility of reusing the same template for different questions. So we've done the electrochemical cell of copper, and I have not given us enough space for that, and aluminum, like that. So again, does this require or produce energy? This is going to produce energy. creates energy. And now we need to justify why we know it is spontaneous and why we've assigned the oxidation and reduction the order that we have. So here's my justification. So first off, I mentioned that the E cell is positive. So since the E cell is positive, this means the flow of electrons from, now we have to think about this when we're thinking about what's happening with that redox reaction. Where are these electrons coming from? They are coming from the oxidation reaction, so they're coming from aluminium. Where are they going? They are going to the copper 2 ion because the copper 2 ion is going to gain them and become the copper element. So this is a spontaneous reaction. So because this is a spontaneous reaction, we're going to be converting the chemical energy that's being stored in these bonds into electrical energy, which can now do some work. I can't spell electrical. So I'm also making sure that I'm clear about that it's producing electrical energy, and I'm also stating the amount of energy that it's being produced. It's a nice little good backup in case you make a silly mistake. So if I want to know how much electrical energy it's producing 2.02 volts. Cool. And even though I have justified how I have assigned my oxidation and reduction half, I'm still going to repeat it just in case. You did explain it up here, but it's nice just to kind of give a backup. So I know that Cu2+ is going to be the oxidant because its standard reduction potential is higher than the aluminum. And that's all you need to do for the excellence. So like I said, it's not too much of an extra step. Questions, concerns, comments? Pretty straightforward, makes sense? Yeah. All right, the last thing you will need to do is the comparison, but I'll talk about that later. I want to show you guys one video just to kind of give you guys an idea of applications of galvanic cells and how the two then link together as well. So let me just pause the recording. All right, I will try to get that video working because it's a nice video to see, just kind of understand the difference between galvanic and electrolytic cells. Some things to keep in mind is that there are situations where you could have both an electrolytic and galvanic cell. The great example would be your cell phones, and that's what that video is talking about. So when my cell phone is not plugged in and I'm using it as is right now, it is acting as a galvanic cell. It is taking that chemical energy that's stored in my battery and it's converting it into electrical energy, which is then powering my phone. Now, this is not an endless supply of energy. As you guys know, your batteries in your phone do die, and your phone then dies and turns off, so you then run out. So that's the end of the galvanic cell and the charge of that galvanic cell. Now, the great thing about our rechargeable batteries is that we can plug it into the wall, and we can reverse the chemical reaction that has occurred in our cells, so that way it then recharges, and then you can use your phone again. It would be pretty useless if you could only use it once. So that is an example of an electrolytic cell. So this has both in there. So because I can plug it in, the electrolytic cell component is now activated. It reverses the movement of the ions, thus allowing my phone to then work again. And it's the same thing with all rechargeable batteries, same thing with your laptop, it's acting in the same way. This is not always going to be 100% effective. The battery does lose its ability to recharge as well, and that's why you'll notice that the lifespan of your battery does die. So that's why you'll notice in your phone that you have to replace the batteries every so often, or you have to just replace the whole new phone because the recharging component is not working as effectively, and so you're not actually getting the full recharge in it. So that's just kind of the downside with some of these batteries. But they are getting better with time. The other thing I like to talk about when we're talking about galvanic versus electrolytic is cars and car batteries. So have you guys ever gone to your car, you turn it over and you notice that it doesn't turn over and it's like a flat battery? It goes and then it just kind of doesn't work. So we need the car battery to provide a spark for the ignition so the combustion engine can work and thus burn the gasoline to then give you forward momentum in your car and how it works. So in order to do that, we need the battery to start that spark. The battery can be drained and die off if you leave certain things in your car on. Say, for example, the headlights. If you leave your headlights on in your car overnight, then when you go to turn your car on the next morning, it's not going to start. What you then have someone do is jump start your car for you. So you'll hook one car up to another car with the battery, and then you rev the engine, you jump start it so that way it's enough energy so that way you can start your car. Now, something that you guys should know with these petrol cars, because some of you guys are, I'm an electric car now, so I haven't said it. But for those petrol cars, when you have your battery, it is really important that after you start it, after it's been flat, that you run your car a good amount of time. You don't want to just turn your car on, drive to school, turn it off, and walk away, because when you come back at the end of the day and you turn your car back on, it's not going to start because you haven't recharged the battery. This is one of the bits of advice my dad gave me when my car battery died. He said you have to drive it for about 20 minutes on the motorway. So what happens when you're driving your car is that the momentum of the car and the kinetic energy that you're producing with the drive is recharging your car battery. And so that way, when you take your car on a nice long drive, you can recharge the battery, and then when you turn off your car, your battery's gonna just die again. So it's something to kind of keep in mind if you ever have a flat battery, restart the car, don't just drive to the supermarket and turn it off, otherwise you're gonna have to deal with the dead battery again. Take it on a good drive, ideally on the motorway, and that'll give it enough juice so that way your battery recharges. Your battery should more or less be fine then after that point if it's just a headlight issue. But again, the lifespan of the car battery does die out, so you will need every so often to replace your car battery, and they will do measurements on there to tell you whether or not it's time to replace it, and so they just remove it and they give you a new one. So do kind of keep that in mind when you're dealing with cars and stuff like that. And when you're dealing with like a flat battery. Cool. Questions, concerns, comments? So yeah, if you leave your car battery, if you leave like the radio on or the light in the car or the headlights, all these things are going to drain the battery of the car. So that's why it comes flat the next day. But so long as you don't do that repeatedly, you're not going to have a flat car to start with. And so long as you recharge it properly too. All right. Cool. One last thing I want to show you guys is this Venn diagram. I don't want to go through it and do notes on it per se, because I think it's very time consuming and it's not a good use of our time. I'd rather us do some other stuff. I will scan it and I will put it onto Google Classroom for you guys to see. But I just want to have this little comparison Venn diagram up so you guys can think about how to compare and contrast the two if you are aiming for that excellence. So for the last component of the excellence, you do need to write a few paragraphs just explaining the difference between electrolytic and galvanic cells. I've written it up as a Venn diagram to show you all the different options of what you could write. I don't need all of them. I think I only really need 2. The Venn diagram is just a shorthand of notes. I would like you guys to write it as a proper paragraph and not reproduce a Venn diagram for me. But I just want to kind of show you guys the similarities and differences, which should be more or less pretty obvious because we have covered both cells in detail. So keep in mind with electrolytic, that is non-spontaneous. The E cell will be a negative number. With the galvanic cell, it will be positive, and that will be a spontaneous reaction. Again, you'll have both your electrolytic and galvanic cells when you write your comparisons. You can bring it up and look at it directly and tell the difference. Something else to keep in mind is because of the spontaneity that helps us determine what type of energy changes are occurring. If I'm dealing with electrolytic, we are going from electrical to chemical. If we are dealing from galvanic, we're doing from chemical to electrical. So that ties in with the spontaneity as well. If you want to add some extra information, you can say that the electrolytic is going to need energy to force the electrons to move in the reverse of its natural direction. Other things, galvanic, you need to figure out which one is the stronger oxidant. You could also compare the setup of these cells as well. So electrolytic, 1 beaker, galvanic, 2 beakers, and a salt bridge. And that salt bridge helps control that flow of, the separation of our redox reaction helps control the flow of electrons because it is spontaneous. If I just mix everything together, the electrons will just be moving in a random order, which isn't useful to me. That's not electricity. The other thing you could compare is you could talk about how the electrolytic is used for purifying elements, electroplating, and recharging batteries, whereas the galvanic is used as a battery. In the middle, we think about things that are similar. So both of these guys have redox reactions. Both of them will have reduction at the cathode and oxidation at the anode. But something to keep in mind that does change in these 2 cells is which one's positive and which one is negative. So the cathode in the electrolytic is negative and the anode is positive, whereas in the galvanic cell, the cathode is now positive and the anode is now negative. So that's just kind of a summary of all the comparison. But most of you guys should be fine with the comparison paragraph. You will be given, like I said, your work from the rest of the assessment, so you'll be able to reference them to help you write your answer. But I will scan this in case anybody wants it, but I think it's pretty obvious which one's which. Cool? All right. Questions, concerns, comments? Nope. All right. So I'll just pause it there.